when the aviation world began betting on speed, luxury, and futuristic interiors. A small team of engineers in Switzerland quietly focused on something far more ambitious, building a jet that could fly farther than any private aircraft in human history. Their creation, known only as the Horizon V7, wasn't revealed at airshows, press conferences, or luxury expos. It emerged suddenly, like a myth becoming real, when it completed a non-stop flight that shocked the entire industry. But the story began long before that moment. Deep in an underground laboratory beneath the Swiss Alps were a group of aerospace researchers, frustrated with traditional design limits, started working on a propulsion system that would permanently change the definition of long-range aviation. They studied everything: military reconnaissance drones, experimental NASA prototypes, high-altitude weather craft, even migratory birds capable of crossing oceans without rest. But nothing shaped the jet more than a breakthrough that came from an unexpected source: a physics researcher who had spent a decade studying the behavior of airflow around mountain ridges. Her research revealed patterns of ultra-low resistance air corridors that form naturally at high altitudes, invisible to the human eye but predictable through complex atmospheric modeling. Using this data, the Horizon V7's designers realized they could create a jet optimized not just for efficiency, but for gliding through these hidden air highways, reducing drag by nearly 22%, a number experts once considered impossible. The engine was the second miracle. Instead of merely improving traditional turbofan efficiency, the team built a dual-phase hybrid propulsion core, a system that blended a next-generation turbine with a high-frequency ion assist chamber. This allowed the jet to operate in two modes: a powerful climb and cruise mode that lifted it to record-breaking altitudes, and a near-silent high-ion mode that dramatically extended its range. The jet could remain aloft for nearly 19 hours without refueling, crossing entire continents and oceans in a single stretch. But range wasn't just about engines. It was also about weight. To solve this, the Horizon V7 was constructed with an ultra-light, nano-layered carbon shell with metallic lattice reinforcement stronger than titanium, yet 40% lighter. This gave the jet a strength-to-weight ratio unmatched in private aviation. Inside, the cabin wasn't packed with unnecessary heavy materials. It was minimalist but luxurious, with floating carbon fiber architecture, advanced climate control that adjusted automatically based on altitude, and smart windows that darkened or brightened using microscopic energy cells powered directly by the jet's ion chamber. The real breakthrough, however, remained a secret, something only a few insiders knew. The jet carried a microscopic energy recovery system inside its wing roots, a network of vibrational harvesters that captured small amounts of kinetic energy during turbulence and converted it into electrical reserves. Every bump, every shift, every vibration contributed to extending the jet's endurance. It was the first aircraft in history to, in a sense, feed off turbulence. When the prototype finally took flight for its range demonstration, only 6 people knew the real goal: fly from Zurich to Auckland without stopping. No private jet had ever attempted such a journey. Non-stop, pilots climbed to a record cruise height of 57,000 feet above commercial traffic, above most storms, where the sky turned dark navy and the curvature of Earth widened below. From there, the jet entered the atmospheric corridor the team had spent years mapping. Hours passed. Then, more 11 hours, 14, 17, and finally, after 19 hours and 12 minutes, the Horizon V7 touched down smoothly in New Zealand with enough remaining fuel to continue another 1,000 miles. The world aviation community erupted. Analysts called it the impossible flight. Billionaires flooded the company with requests. But the jet wasn't for sale. Only 3 models would ever be produced, each reserved for strategic partners invested in the next phase of ultra-long-range aviation. What made the Horizon V7 legendary wasn't just its performance, it was what it represented. A complete shift in how jets were designed, prioritizing range over opulence, physics over flash, science over speculation. Larger corporations quickly tried to replicate the design, but none could replicate the exact mixture of materials, algorithms, and propulsion tuning that made the V7 unique. And while the public will hear only fragments of the true technology behind it, insiders know this jet marks the dawn of a new era, one where private aircraft can fly across the planet on a single breath, linking cities once separated by day-long journeys and redefining what is possible in human travel. As the sun sets behind the horizon, V7 parked on its private runway, glowing faintly with blue ion resonance, one thing becomes clear: this isn't just the longest strange private jet ever built. It's a glimpse into the future of global flight, a future where distance no longer matters, and the horizon is no longer a limit but an invitation.